aware. Let's continue with our journey to master Euclidean geo. So here we go. Another question. This one is looking a bit more complex. You know the story. The more complex it is, the smarter you get. So let's work on it. What is given to us? We are given RST as a tangent. Let's go and highlight that because it's very, very important. We're going to make use of it to the circle at S, which means this tangent is touching the circle at point S. And then OS is a diameter. You will never be given something that you ain't going to use to answer your question. So definitely sure we are going to use the information for the tangent and also the diameter that is given. And US is equal to ES and is equal to VS. Those are sides, or those are lines being equated to each other. Now we know. Let's go to questions. So what are the questions? So if E2, angle E2 is equal to X, where is angle E2? Let's go and identify that. It's very, very important to start by identifying what are they talking about. Where is it? Where is it? There you go. There is E2. Okay, you can see it. Here you are. And then now they're saying find 6 other angles that are also equal to X. Here, 6. Okay, let's go. We're given tan chord, so we're gonna use tan chord, definitely sure. Okay, which one? It's S2. S2. Here you go. S2 is an angle between a tangent RST and the chord US. The chord is subtending the angle E2, and E2 is at the circumference. So angle S2 is equal to angle E2, and they are both equal to X. How come? Tan chord theorem. So that is tan chord theorem. Another one. So now we know we have X here. Okay, let's go for another one. This one is equivalent to O1. So O1, O1, angle O1 is equal to angle E2. And they are equal to X. Why? It's because of same segment. Angles in same sec. How come do we have a same sec? Bow tie. Bow tie. Angle O1, here you go, here is it. And then a bow tie is formed also by angle O2. Can you see that? So they are on the same segment. So now we have another X there. Right. Which other angle equal to X? It's U2. It's U2. Angle U2 is equal to X. Okay, or is equal to E2 and is equal to X. How come? It's angles opposites equal sides. Angles opposites equal sides. Right? Or equal sides subtend equal angles. Which are those equal sides? It's ES. ES is subtending E2, and then US is subtending E2. ES subtending U2, and then US subtending E2, and then both US and ES, they are equal, which means they're gonna subtend equal. They're gonna be subtended by equal angles. So now we have X also here. Now 1, 2, 3. Let's go for another one. Same sec again for O2. Angle O2 is equal to X, or is equal to E2. Is equal to U2. Sorry, is equal to U2, and then you're equal to X. How come? Again, another angles in same segment. Right? How come do we have same segment? Let's form a bow tie. Do we have a bow tie for both? Yes, here you go. Yes, here you go. Here you are. Here you are. Same sec. Bow tie is formed. So this is X again. Now let's check for tan chord. We have used tan chord for once, and then let's go for it again. Let's check if we can be able to get something. Yeah, we can. So S5, angle S5. There is angle S5. It's an angle between a tangent, and then a chord ES. subtending which one? Subtending that one, subtending U2, and also subtending O2. So it's up to you. You equate it to U2 or O2, but it's equal to X at the end of the day. And then Y, tan chord. 1, 2, 3, 4, 5. Now we're left with only 1. So since this one is X, which one do we go for? Remember, we have a diagram outside here. S1, S1 is equal to S5 and then is equal to X. How come? They are vertically opposites. Let's make sure you can see that. There is S1, there is S5. And stay vertically opposite. Let's form an X. Here is a line forming an X. There is a line forming an X. Isn't it? And stay vertical opposite. They are. So vertically opposite angles. Done. Now we have got all the angles that are equal to X. Okay. What else? So the following question is asking us to prove that okay, let's leave these. Now it's asking us, okay, let me bring back the x's. So it's X for you, X for you, X for you, X for you, and X for you. Okay, might help. Okay, so now 24.2, prove that EU is parallel to RST. RST, remember, it's a tangent. EU is just a line within a circle. Where is it? Let me go and highlight. Here is EU. There is RST. You're supposed to prove that these lines are parallel. How do you prove that lines are parallel? You should prove by alternating angles being equal, corresponding angles being equal, co-interior angles being supplementary. Co-interior, nah, it's out because we're not working with values for now. Corresponding, it's going to be difficult because corresponding is something like, it's going to be difficult. We're going to have to work it here. Nah, it ain't going to work. It has to be here. Nah, not going to work. So let's go for alternating. Obvious. We've just proven that S5 is equal to X. And then also we have E2 as X. So is it forming a Z? Are these angles forming a Z? Yes, they are forming a Z. So we can then say angle E2 is equal to angle S5, and they are equal to X, both equal to X. Therefore, UE is parallel to RST. Why? Alternating angles equal. So that is why. And then the last one, prove that RUSV is a cyclic quad. So we have different ways to prove cyclic quad, right? Let me not erase everything. We have different ways to prove cyclic quad. It's either you prove making use of corresponding the exterior angle of a cyclic quad being equal to the interior opposite. The second one is opposite angles of a cyclic quad are supplementary. And then the third one you can prove by angles on the same segment being equal. Let's go. Which one is going to be easy? Remember, now we are supposed to prove that this is a cyclic quad. Let's go and highlight the cyclic quad that is supposed to be proven. The diagram that is supposed to be proven as a cyclic quad. This is the diagram. So how can you prove? We can prove by making use of an exterior. Do we have exteriors? Yes, we do have this one and this one. Which one is going to be easy? Which information we haven't used? It's what? Diameter. Diameter is subtending 90 degrees. Is subtended by an angle of 90 degrees, which means there we have 90 degrees. So OUS is equal to 90 degrees. That is what we know so far. And then another thing that we know is that, okay, now we're supposed to prove that if this is 90 degrees, that means this one should be also 90 degrees. Okay? Or we might prove that if this one is 90 degrees and then also this one is 90 degrees, they are adding up to 180. Opposite angles of a cyclic quad are supplementary. And then obviously U1, because this is U1, it's going to be 90. Because now we have this 90 and then angles and the straight line, they add up to 180, which means we have 90 also here, right? So now we already have 90. So now how are we going to end up going for V? Because you can see V is on a different triangle. We have two triangles there. Excuse me. We have two triangles. We have this one, right? We have this one, and then also we have that one. That one now we have worked out 90 degrees. So how are we going to get to the other one, to V? The only way we can do that is to start by proving congruence, right? So let's go for proving congruence. So in triangle URS and triangle RVS, right? What do we have there? We have, remember, when you are proving congruence, you can prove by sides and also angles. It's unlike similarity. Similarity you prove by equating angles, equiangular. But this time we can use, so RS is equal to RS. For both triangles, they share RS, so it's common. It's common for both. That is what they share firstly. And then also S1, angle S1 is equal to angle S2. Why? They are both equal to X. So both equal to X. And then the last one is what? It's R1 and R2. That's an angle. Which one can we go for next? So it's sides. Oh, we also have equal sides there. It's US. Remember, US is equal to VS. Why? It's given. It's given. So we have proven three things. So we have proven about three things. So therefore, triangle URS is congruent to triangle RVS. That is that. So now therefore we can then say, therefore angle U is equal to angle V. Why? Congruency. It's because of congruency. Normal, you can just say it's triangle URS congruent to triangle RVS. You can say that. Right, so therefore that means now V is 90 degrees now, and then opposite angles, if they are both 90 degrees, they add up to 180. Then you can conclude, therefore RUSV is a cyclic quad because the opposite angles are supplementary. That's the reasoning behind it. Away. What